So in this video we're going to look at how to actually identify sine and cosine transformations. If you haven't gotten a chance to watch the two previous graphing videos, which were the wave vocabulary and the sine and cosine parent functions, please make sure you go back and look at those videos, at least make sure that you understand the information in them, because that information is going to be really vital to finding out what these transformations are and what they actually mean. So in just a second, I'm going to go over to the next slide, and it's going to have two really crazy equations that are going to seem really complicated, but just bear with me, take a minute, and we'll explain through those. It's really not that bad once you get used to it. So without further ado, here are those equations. And again, they look really complicated. There's a lot of variables, there's no numbers to it. A lot of students tend to get bug-eyed when they see this. But this really shows all the different possibilities that you could have in a sine or a cosine wave. It's very, very unlikely that you'll have every single one of these. So let's go ahead and figure out what exactly each one of these does. First, there's that plus or minus sign up here. So in both of these equations, every single one of these means exactly the same. The only difference is whether it's a sine or a cosine curve. So the plus or minus is going to tell you whether it's reflected or not. So this right here is your reflection. If you have a positive, then there is no reflection. And if there is a negative, then you do have, it is reflected. So this right here is just your reflection. If you remember your parabolas, then it did the same thing. This plus or minus out front ended up reflecting that parabola. The next thing to look at is this A. And in this case, the A is going to be your amplitude. So again, the amplitude is the distance from the midline to the crest, or the distance from the midline to the trough. Because it's distance, you're never, ever, ever going to include this positive or negative to it. The positive and negative deals with reflection. Amplitude is simply just a number. You don't have to worry about a positive or negative to it because it's a distance. The next thing is whether it's a sine or a cosine curve. And this next one ends up being one of the things that confuses students the most from what I've seen. The B, all it does is it helps with the period. So this is the only one that doesn't flat out tell you what it does. The B value is going to help you find the period. And you do so using this equation right here. Your period is equal to 2 pi over b. So if you take a second and think about this equation, your period is the length of one full cycle. And on the parent function, sine and cosine, one full cycle was 2 pi radians. Because after that, it was on a unit circle and everything started to repeat itself. So this equation right here is actually how many rotations, so this B stands for how many rotations, fit inside of 2 pi radians. So really it's for every 2 pi radians, how many rotations do you go through? And we'll see a little bit more of how that works in just a moment when we start identifying things. This next one is called a phase shift, also known as a horizontal shift. And in our class, we don't have to worry about the phase shift or horizontal shift. So if you came here looking for that, I apologize. It's just not something we're going to end up going over in this video. Which means that the last thing we're going to look at is this right here, and this does include the plus or minus. This here is your vertical shift. And your vertical shift, what it actually does is it shifts your midline. Shifts the midline. So personally, what I would do if I were you is I would pause this and make sure to take those quick little notes on what each of these does, because what we're about to do is see a bunch of different graphs and try and figure out what the original equation was just using this information here. So at this point, again, pause if you need to take those notes. And we're going to go ahead and move on to the next thing. So here's the first little example for us, and I'm going to walk you through my thought process. So I made this curve, and I know what the equation is, but you guys obviously don't. So let's try and figure out what it is just by looking at this curve. So the first thing that I need to do is I'm going to try and identify the midline. identify the midline. And the midline is, again, it's an imaginary line, and it's going to be horizontal. So it's the horizontal line of symmetry here. So as I look, I want to try and figure out, all right, where is about halfway between this crest and this trough? And it's going to end up being somewhere along this line right here. So potentially right now, I know that my vertical shift is going to be, oops, sorry, still got the big marker out. My vertical shift is potentially plus 0. I'm still on the x-axis, which means I didn't shift that midline up or down at all. Typically at this point, the next thing I'll do is I'm going to identify if I'm looking at sine or cosine. Oops, sine or cosine. And the way I do that is by looking when x equals 0. So at x equals 0, am I at a midline, a crest, or a trough? So if I'm at a midline, then I'm going to be looking at the graph of sine. The graph of sine is always going to start at the midline. Whereas if I'm looking at a crest or a trough, then I'm going to be looking at a graph of cosine, because that's where cosine is going to start, either a crest or a trough. And you'll see why a trough potentially in just a moment. But I'm going to go ahead and look at this. Our graph at x equals 0, we're at the midline. So if I'm at the midline, that means that I'm looking at a graph of sine. I can go ahead and pretty confidently say that this is the start to our equation. Oh, should start with a y equals. At this point, now that I've identified where the midline is and whether we're looking at sine or cosine, we can go ahead and determine if we've reflected. So if we've reflected, what that does is that's going to flip the crests into troughs and the troughs into crests. So a crest becomes a trough, and a trough becomes a crest. That's what happens if you reflect the graph. So we know from the parent function that a graph of sine should start at the midline and go up to a crest. So because this graph goes up to a crest, we're going to say that this graph is not reflected, which means that we start with a positive. If it had gone down to a trough, then that means that we did in fact reflect, so it's reflected graph, and this would have been a minus. But since we went up to a crest, we're still positive. At this point, I'll look at the amplitude of the graph. And the amplitude, in case you've forgotten, is from the midline to the crest. It's that distance, or it's the midline to the trough. In this case, the distance between those, we've got 1, 2 units. And just to double check myself, I'm going to make sure it's the same over here. 1, 2. Yes, because it's the same, I know that the amplitude is in fact 2 on this graph. If they had been different, then right off the bat, I know that my midline is incorrect. The midline physically splits it in half. So if I don't have the same going from midline to crest and the same midline to trough, then I know that I've made a mistake. The last one is going to be our period. So we want to see what the length of one full cycle is. So in order to do that, I'm going to start at, it seems like there's no real definite place to start. I personally just like to start at x equals 0. So I need to go through one full crest and one full trough. And just because I've done a lot of these, it's going to be at 6 point something. Normally, it would be a little bit more explicit than that. I know in my worksheets, I'll actually label it in terms of radians instead of just 1, 2, 3, 4, 5, 6. Radians with pi's and all that. So I'll go ahead and tell you guys, it actually has a full period of 2 pi units. So this is about at 6.2 blah-de-blah-de-blah, which ends up equating to 2 pi. So this is where we're going to do a little bit more thinking and a little bit of algebra. We know that period is equal to 2 pi over b. And we just discovered that our period is 2 pi. So we can go ahead and write an equation and say our period, 2 pi, is equal to 2 pi over b. And then in order to solve for b, we multiply both sides by b. And at this point, hopefully we can recognize, oh hey, b is going to be 1. So 2 pi times b equals 2 pi. The only way that's true is if b is 1. So we've just created the equation. Now it's time to get rid of a little bit of the clutter. The positive is just assumed, so we can leave it as b. Times the sine of 1 times x. Well, again, the 1 is just kind of assumed. And then plus 0, that's kind of just assumed. This is the equation of that graph. And now we're going to look at something a little bit more complicated. The rest of this video is just going to be us going through a couple of practice problems. So what I would encourage you to do is when I show this graph, go ahead and pause. If you need to, go back and look at these steps, but pause it and see if you can try and figure out what this is before I figure it out on my own in the video. So at this point, I'm going to kind of talk through these steps, and I'm not going to write them all down because that is going to take a little bit more time. The first thing I'm going to do is identify the midline. And again, it looks like it's probably about right here, which means we have not shifted up or down at all. So I can confidently go ahead and put on the back side of our equation that we've got a plus 0. Now I'm going to look at whether we're looking at sine or cosine, and it really doesn't matter what order you do these in. So if I end up mixing up the order a little bit, it's not that I'm doing it wrong, it's just it doesn't matter quite as much that order that you go through, as long as you hit all those points. This is just what I tend to find the easiest. So graph of sine or cosine. Well, here's x equals 0. I'm starting at a trough. So because it's a trough, I know that I'm looking at a graph of cosine. And actually, this is an important bit here. I'm going to go ahead and skip over to the reflected. I know for a fact that this graph is reflected. The graph of cosine should start at a crest. But since we're starting at a trough, we've got a reflected graph here. Don't forget your y equals. That's the only way it's going to be an equation there. So now we look at it and we say, well, the amplitude of this bad boy from the midline to the trough and from the midline to the crest is both 1. And the last thing to look at is going to be our period. So as I look at this, if we're looking at one full cycle, I'm going to again start down here at our x-axis. And so here's half of a trough, a full crest, the other half of the trough. And again, some of you probably can estimate it, but I'll go ahead and tell you it's going to be pi. So our period this time, our period is equal to 2 pi over b, and I still got that thick marker out. Let's go ahead and change it. We just discovered that our period is pi. So again, with a little bit of rearranging, multiply by b. We say b pi is equal to 2 pi. We're looking at this, we can say, all right, well, that probably means that b is equal to 2. And you can prove it by dividing by pi. But now we've just proved that this right here is going to be 2. Don't forget our other variable. And now it's just about getting rid of that extraneous information or the extra information. So y equals, we can ignore the 1 because it's always assumed that there's multiplied by 1. Cosine of 2x. So here is our graph from there. We've got 2 more that I'm going to look at. Again, encourage you guys to try and figure out what the equation is before me. So here comes that next one. In this case, we're going to start and say, all right, let's find that midline. And right off the bat, I can see that it's not on the x-axis. This is very obviously not the midline, so we know that we've got a vertical shift in this graph. So here's my approximate midline, and I'm kind of eyeballing it. You can always double check yourself by counting the number of blocks and making sure that it's the same up and same down. But typically you're going to be in the ballpark when you look at those midline shifts. So I can go ahead and say y equals. I know that there is going to be a midline or a vertical shift here. So what I'm going to say is I'm going to try and figure out what did it do to go from there to there. Well, we know we went down, so right off the bat we can say that it is a negative number at the end. And how far did it go down? Well, it went down to 2. So it went down 2 units. I can go ahead and put that it is equal to -2. So our vertical shift is down 2. At this point, I'm going to go ahead and discover whether we're looking at sine or cosine. At x equals 0, our graph is at the midline, which tells me that we're looking at, wrong color, tells me that we're looking at a graph of sine. Looking at that amplitude, it's a little bit harder to figure out, but from looking at this, we can assume every 2 boxes is going to be 1 unit. It doesn't work well when you write it in white. So there's 1, there's 2, there's 3, there's 4. Sorry, all these are negative because we're below that x-axis. So 4, here's -5. If I count the boxes from the midline to the crest, and then from the midline to the trough, I'm going to discover that we're traveling 1, 2, 3 units down, or 3 units up. So the distance from the midline to the crest to the midline to the trough is 3. At this point, I'll go ahead and decide that I'm going to check to see if it's reflected. The graph of sine normally goes from midline to crest. We do that, so it's a positive. There is no reflection. And the last thing is going to be figuring out this period. So again, I'm going to start when x equals 0. 1 full crest, 1 full trough. Brings me right here, which again, I'll go ahead and say is 2 pi. You start to get a feel for where these end up going. Also, I'm cheating a little bit. I've got the answers in front of me. Plus, I'm the one who made them. So looking at that equation, the period is equal to 2 pi over b. We just discovered, because 1 full crest and 1 full trough fits into 2 pi units, that our period is 2 pi. Again, looking at this, we can say, all right, well, that b is going to be 1, but you can prove it by going ahead and multiplying by b and solving for that variable. I'm going to go ahead and skip that because I did that 2 problems previously. But we do discover that b is equal to 1. So again, I'm looking at 1 times x. Last step is to get rid of extraneous information. The positive is just assumed to be there. Sine of x, again, the 1 is just assumed to be there, minus 2. Now we're heading over to the very, very last one. This one does put a little bit of a trick to it. So make sure that you guys give it a shot. But if you end up making a little mistake, don't worry, it's to be expected. So let's start this off like we normally would. Again, you would never know that there was any sort of trick until I told you that something funky is going on. I'm going to identify that midline here. Just eyeballing it a little bit. And it looks like it's not moving at all. So we're still on that x-axis. I'm going to go ahead and put, excuse me, still have that big marker out, plus 0. And now because I'm starting at x equals 0 up here to crest, we know that we're looking at a graph of cosine. The next thing to look at is, let's go ahead and figure out if we're reflected or not. Well, we start at a crest, so no, we are not reflected, which means we've got a positive. In terms of figuring out our amplitude, we can count out and say each box, it looks like every 2 is going to be 1 unit. So 1, 2, 3. So from our midline to our crest is 3 units. And midline to trough, 1, 2, 3. Agreed. So we've got a amplitude of 3. This is where things get weird, though, for that period. Because normally we would say, well, let's start here, and let's do 1 full cycle. We say I can do half of a crest and a full trough. So instead of a full cycle, we can extrapolate information from half of a cycle. So half of a crest, half of a trough. Well, that whole thing is going to take us 2 pi units. So I'm going to think to myself here, if a half cycle is 2 pi, then a full cycle has to be 4 pi. Because logically, if this is half of it, then the other half is going to also take another 2 pi. So by that, doing a little bit of thinking, I'm going to go ahead and say that 1 period, again, still equal to 2 pi over b, but I'm going to say our period is 8 pi. And again, this math is going to be a little bit different from what we've done previously. Let's go ahead and multiply both sides by b to get that b out of the denominator. And we get b times 8 pi is equal to 2 pi. This one might not be as obvious as to what you're going to do to solve it, so I'm going to go ahead and divide by 8 pi, get that variable by itself. So I'm going to take a little bit more steps than some people normally would, just so that you can see that thought process we're going through, because I know a lot of people aren't super comfortable with fractions. Because I've got a pi in both the numerator and the denominator, and it's being multiplied, I can cancel those out. So now I'm left with 8 over 2, which can reduce down to 1/4. So my b value is going to be 1 over 4, and I put in my variable. As we're simplifying, I'm going to also simplify that fraction. I'm going to change it into x over 4. And if you don't see why that is, I'm just going to go ahead and say it. I'm going to tell you why it is, and then we're done with the video. So if you understand why that is, then just go ahead and move on to the next thing and start working on homework or classwork or studying for that test or quiz that you guys have coming up. If you don't see how this came about, let's go ahead and go off into a thought bubble and see what was going through Mr. Raymond's mind here. So what I saw is we had 1/4 times x. Well, in case you don't know how to multiply a fraction and a whole number, what I do is I change them both into fractions. And when you're multiplying fractions, it's just going to go straight across. So x over 4, and now suddenly we can go ahead and say, oh, there it is right there. So again, that's the end of this video. Hopefully this helps you identify what those equations are based off of the graphs themselves. In the next one, we're going to be looking at how to create the graphs using the equations. So here we went from graphs to equations. Now we're going to go from equations to graphs.